CR circuit has a frequency response. Frequency response means low pass or high pass filter. How it can act? First low pass we have to see. To design a low pass filter using the capacitor and resistance to study the frequency and phase response of the CR circuit. Clear? So for this, what are the operators we are going to take? First is signal generator, 2.2 kilo ohms resistor and 0.01 microfarad. 0.01 means 103. 2A J 103 J capacitor you have to take, that is a 0.01 microfarad capacitor. 2.2, 2.2, 2.2 once you have to check in the multimeter you have to check it. So which one we are getting once you have to see 2.1 kilo ohms. 2.1 kilo ohms we are taking because it is a low pass filter, that's why we have to take it as a low resistance low pass filter, that's why we have to take the low resistance. First, signal generator positive to resistance 1 and we have to give for the low pass filter, correct? Next, signal generator negative, where we are going to give the ground. Signal generator negative is ground. Later, resistance another end we are going to connect. Which one it is? This is the capacitor 10103 capacitors. 103 capacitance means which one we are writing, take the ground, right? Directly I am giving into the ground connection, ground I am giving, right? Next, so AC voltmeter, because we are applying the function generator now, this is the AC, so that's why here AC voltmeter we have to take. AC voltmeter, in AC voltmeter here input we have to take and output also we consider, correct? For input purpose, where we are taking the input, wherever the signal generator positive is there we are going to take the input. Wherever the signal generator another end is there, so we are going to take capacitor and capacitor end is there now, there we have to take the output. First you have to switch on, okay? So once you have to switch on, how we have to take the observations? Once you have to see, you apply the 100 hertz frequency. 100 hertz you have to apply here, right? 100 into 1, 100 into 1, 100 hertz frequency we are applying. 1 into 100, 1 into 100, 100 hertz frequency we are applying, correct? Now you switch on this train. So first what we have to take? First input voltage we have to measure. How much input voltage is there? 0.24 is there. Next, for 100 hertz what is that output? Output you have to measure, right? Input you have to write here 0.28, output you have to write here 0.23, right? This is the thing. Next, 200 hertz, 200, 100 into 2, 100 into 2. Input, how much input is there you have to see, changing now. Now how much output is there you have to see, changing now. How much output is there you have to change. Like this you have to take different frequency ranges you have to apply for different inputs and outputs you have to take, and you draw the curve. So once you have to draw the curve, log f versus gain you have to take, the curve will come like this, the curve will come like this. There, this is the maximum gain. From maximum gain into 0.707 you have to multiply. This intersection point you have to extrapolate like this. Wherever the coincident is intersect here, that you extrapolate to in x-axis, that is a high cutoff frequency. Because it is a low pass filter, there is a high cutoff frequency is there. That high cutoff frequency is f naught is equal to 1 by 25 RC. Theoretically also we have to calculate, correct? So this one is a high cutoff frequency. High cutoff frequency, low pass filter means low frequencies are allowed, high frequencies are cutoff. Low frequencies are allowed, high frequencies of cutoff. How we have to calculate the phase? By using the phi is equal to minus tan inverse omega CR, where omega is equal to 2 phi f. You know the omega f is equal to, 100 hertz, 500 hertz, 1000 hertz, 1500 hertz, 2000 hertz is there. So for each and every frequency value, you calculated the theta value, and then you have to take the graph. That graph is negative axis, it will come because it is the negative sign is there. So that's why in the negative axis is there. This is the log f versus 10 to the theta we have to take. This is a low pass frequency. Now we are going to discuss about the high pass frequency. How we have to write the high pass frequency? Once you have to see, wherever the resistor is there, no, this resistor you have to take at the output side. Output side you have to take the resistor, right? So the resistor you have to take output. Whatever the input is there, capacitor, this input capacitor you have to keep here. Similar procedure you have to follow. Which procedure you have to follow? Similar procedure you have to follow, right? So once you have to take this one, similar procedure you have to follow. What is that procedure? Once you have to see, first you have to apply the 100 hertz frequency. 100 into 1, 100 into 1 means 100 hertz frequency. Now you able to see the input. How much input is there? You have to see how much input is uh, how much input is we are applying. You have to see, you will get the input value. Next, what you have to take for corresponding that input, how much output is there, you able to see the output for corresponding to that input. How much output is there, you can see, right? And there you change the input value, frequency you have to change 2, so 4, 5, 6, and so for corresponding that input you have to calculate the output values, you have to calculate and find the gain. So and find the gain. After taking the gain, you take the graph. So now the graph will come like this. Gain versus frequency log 10 graph will come this. Now you have to take, this is the maximum gain. This is the gain maximum. You multiplied with 0.707. There is a one intersect point is there. You correspondingly extrapolate like this. There is a low cutoff frequency, it will come. That low cutoff frequency also 1 by 25 RC only. 1 by 25 RC only. Correct? So how we have to calculate the phase? Here phase is equal to tan inverse 1 by omega CR. Tan inverse 1 by omega CR. Why the formula is changing? Because output is taking across the resistance. So that's why we are taking. Here there is no negative sign. Therefore, if you have to take the frequency versus theta also, you are getting the curve like this. So by using this, what we have to tell the result, the high frequency filter has been observed, and it allows the high frequencies, and it blocks the low frequency range. That's why this one we call it as a high frequency. Similarly, in low frequency, it allows low frequencies and blocks the high frequencies. Here it allows the high frequencies and blocks the low frequency. So that's why RC circuit can act as a low frequency and high frequency. So this is the theory. Theory we are doing with the experiment to take the graphs and to calculate the cutoff frequencies. From that we have to tell the result. Thank you.